In the last video, we learned how to translate English sentences into propositional logic. Before that, we learned how to do truth tables. And now we're going to give names to formulas that have certain configurations of truth values in their final column for their truth table. So we'll learn about tautologies, contradictions, contingent formulas, and then we'll also talk about how entailment is represented in logic. So we say that a well-formed formula alpha is a tautology. So that is tautology if it is true under any assignment of truth values. So basically what this means is that in the final column for alpha, once we've done all of our different situations, we should end up with only ones in that final column, and that's a tautology. We also use the symbol, this looks like a capital T. It is called the verum. It comes from the word veracity for truth. So it's something that is always true. So I have some examples here. The first one is a nice and classic example. It is P or not P. So let's just do the truth table quickly for P, not P, and then we'll be able to get P or not P here. So there's two different configurations of P. Either it's true or false. Not P would then be false and then true, since it's the opposite value. So if we take either P or not P, that's true if at least one of those is true, we find that they're true in both cases. Like, this number is even or it's not even. This is a vowel or it's not a vowel. These statements are always true. Another example that we can do is P arrow P. So in this case, in the first row, we have 1 arrow 1. So this gives us true. In the second row, that would be 0 arrow 0, which also happens to be true. So P arrow P is another example of a tautology. Now, if we have a more complicated truth table for P arrow Q arrow P, we're going to find the same thing. So let's clear this up a little bit, and let's draw out a full truth table for P arrow Q arrow P. So I have PQ, I'm going to need a column for Q arrow P, and I'm going to need a column for P arrow Q arrow P. So Q is going to give us 1, 0, 1, 0. Okay, what do we get for Q arrow P? So it's going to be false when Q is true and P is false, so it'll be false in the third row, and in every other row, it will be true. Okay, so now we have P arrow Q arrow P, so we're taking a look at the P column, we're taking a look at the Q arrow P column, and we're going from P to Q arrow P. So in the first row, we have 1 to 1, well, that gives us true. And the second row, we have 1 to 1, which is true. In the third row, we have 0 to 0, which is true. And in that fourth row, we have 0 to 1, which is also true. So as we can see here, P arrow Q arrow P is also a tautology because every value comes out to be true. So that is a tautology. The next one we have is a contradiction. This is used the upside down looking T. This is called the falsum. You can probably guess what word comes out of falsum in English, but a contradiction is always false under any assignment of truth values. So if we have alpha, we expect that basically everything under alpha is going to be false. So an example of this is going to be P and not P. And I'm not going to do all of these because the second one is quite long. So P, not P, and then we'll have P and not P. So if we do the truth table from before, P is true false, that means not P is false true. So in order for P and not P to be true, we need to have that both P is true and not P is true. But in both cases, we find that only one of those is true. So as we can see, for the truth table for P and not P, this is false in every situation. Oops. Okay, now I want to do not P or not P. Not P or not P. And I can kind of take a little shortcut here because we just did P or not P, right? So we just found that for the P column, if P is 1 or P is 0, P or not P is true. So of course, if we take the negation of P or not P, we're just flipping the truth values of P or not P. So that gives us 0 and 0. So not P or not P is a contradiction. Basically, anytime you take a tautology and you negate it, what you get is you get a contradiction. Similarly, if you take a contradiction and you negate it, what you get is a tautology. So you can check the other one yourself if you want, but we can kind of talk through this. We can sort of explain why this is a tautology. Uh, Here in the center, we have this formula P or Q is the same thing as Q or P. Now we know intuitively just with words this is true, because P or Q is exactly the same as Q or P, and the biconditional has the sameness. So if we negate this whole thing, then we're essentially negating a tautology. So the negation of this is going to be false in all situations, which gives us a contradiction. So it's a good idea to do the truth table anyway, but for some of these, if you're really comfortable with logic, like if you've taken another course in logic before, or you happen to pick up on this really quickly, you can work through some of these just through familiarity and thinking about them in words. But if you're starting out new, and this is the first time you're seeing these things, please just do the truth tables. Do not trust your intuition yet. Trust your intuition more when you've done a lot of practice. So if you do a truth table for this, what you'll find is once you negate everything, you're going to have 4 zeros in it. The last type of formula is called a contingent formula. And a contingent formula just means that you have some ones in places and you have some zeros in other places. So it could be any configuration. As long as you have at least 1 0 and at least 1 1, you're in a good spot. Basically, contingent formulas are just, it depends on the situation. It's true in some situations, it's false in another. So a really simple one is just any atomic statement P. Because if you just have P on its own, well, yeah, P is true or P is false. There's an option. There's a 1, there's a 0. We have both. It's contingent. What about, let's do P arrow Q. So I need a column for Q. I need a P arrow Q, and I need a P arrow Q. Okay, so let's just move some things around to give myself more space. And let's fill out this truth table to start it up. Okay, so P arrow Q, it's false when we have P is true and Q is false, so it's going to be false in the second row. It's going to be true in every other row. Now we're going to do P to P arrow Q. Okay, so in the first row, we have 1 arrow 1. That gives us a 1. In the second row, we're going to have 1 arrow 0. So that's going to be false. At this point, if we want, we can stop. This is fine, because we know there's a 1, we know there's a 0. Therefore, we can say that it's contingent. But for the sake of completion, let's keep going. In the third row, we have 0 arrow 1. That gives us 1. And in the fourth row, we have 0 arrow 1 as well, which gives us 1. So that'd be the complete truth table for P arrow Q. Okay. Now, with something like P or Q or R, it's just 3 different atomic statements with or between them. So the only thing that we're going to have are a bunch of conditions where P is true, P is false, Q is true, Q is false, R is true, R is false. So they're going to be true when at least one of those is true, and it's going to be false when we have P, Q, and R false at the same time. So we could draw a complete truth table for this, or we could just figure out one condition where it's true, one condition where it's false, and we can say, okay, it's contingent because we can find one of each situation. So again, if you're comfortable with it, you can do it that way. If you're not so comfortable, draw out the complete truth table. The last one to talk about is entailment. And remember how entailment works. We said that if we have a sentence A entailing sentence B, this means that if A is true, so if A is 1, then B has to be true. So in other words, it's false when A is true and B is false. That's when entailment does not work. Now, what does this remind you of? Well, this reminds you a lot of A arrow B. In fact, it's the same thing. Logically, we use the conditional to represent entailment. So, if we say that a well-formed formula alpha entails beta, what this means then is that alpha arrow beta is always true. So basically, that would mean there's no situation where alpha happens and beta doesn't. So we can do this with a truth table as well. So let's say I want to show that P and P arrow Q entails Q. So what this means in terms of what I want to construct is that means I want to show that P and P arrow Q is always true. So in terms of entailment, if we think back to our sentences, A entails B, we're picking our antecedents to be A, and we're picking our consequent to be B. So that's what's happening here. P and P arrow Q, this is our antecedent, Q is our consequent, we put an arrow between it, and we want to show they're always true. So I have a truth table already drawn out for this. And at this point, you should be able to follow along with this. We've done quite a few of these. So we have 1, 1, 0, 0, 1, 0, 1, 0 for P and Q. For P arrow Q, it's going to be false in the second row. We've done this a couple times already in this video. For P and P arrow Q, that means that P arrow Q both have to be true. That only happens in the first row. In the second, third, and fourth row, these are all false. Now, when we do the arrow for P and P arrow Q, so we're taking a look at the fourth box here, we're taking a look at the second box here, and we're going from P and P arrow Q to Q. In the first row, we have 1 arrow 1, which is true. In the second row, we have 0 arrow 0, which is true. In the third row, we have 0 arrow 1, which is true. And in the fourth row, we have 0 arrow 0, which is true. So what we found is that this conditional, P and P arrow Q is true in every situation. That's a tautology. Therefore, we know that P and P arrow Q entails Q. So this might have to be something that is sort of memorizing in the sense that entailment is the same thing as a conditional. But once you've got that down, you're really just looking for tautologies. So entailment is really just a conditional that is a tautology. And the reason is because if A entails B, there's no situation where A is true and B is false. Therefore, A arrow B always has to be true, and that's what the truth table is proving. So, as an exercise, I want you to show that the following statements are true. So P arrow P is a tautology. Well, looks like we just did that one earlier. Not P arrow P is a contradiction, and P or Q and not Q entails P. So if you want to try A again on your own to make sure you can do it here. I will not go through this. Oh, wait, did we do this example before? Let me just double check to make sure that we did do it. Yes, we did do it. P arrow P. So we just did this example. So A is already done for you, but if you want to try it again on your own, please do it. What I will do are these last two. So, not P arrow P. Well, we've already shown earlier that if we have P, and that's 1 or 0, P arrow P is true in both situations, since 1 to 1 is true and 0 to 0 is true. So when we negate this and do not P arrow P, we're just flipping the values of P arrow P. So that's going to be 0, 0. Therefore, this is a contradiction. Okay, let's do this last one here. We want to show that P or Q and not Q entails P. So whenever we see this and, we can just translate this as an and. And whenever we see the word entails, we can translate this as an arrow, and we want to show that this is a tautology. So what we're doing is we're doing essentially this formula. P arrow Q and not Q. This gives us P. So that is what we want to show as a tautology. So we're going to need a column for P, we're going to need a column for Q, a column for not Q, a column for P or Q, a column for P or Q and not Q, and then a column for P or Q and not Q, arrow P. So a little bit more involved than the other ones we've done before. That's okay. It's the same process. We're just building a truth table, and then we're seeing what the ones and zeros are in our final column. That's all we're doing. So Q, 1, 0, 1, 0. When we negate Q, we're flipping the values. So instead of 1, 0, 1, 0, we're going to have 0, 1, 0, 1. For P or Q, this is true if either P is true or Q is true. So this is just your standard truth table. It's going to be true in the first three rows because at least one of P and Q are true. In the last row, it'll be false because neither P nor Q are true. For P or Q and not Q, we're comparing the previous two columns, and it's going to be true when both of those columns are true. So that only happens in the second row because not Q is true and P or Q is true. In the first, third, and fourth rows, that is false because in the first and third row, not Q is false, and in the fourth row, P or Q is false. So now our last one is we're taking this column, P or Q and not Q. We're taking P and we're doing the conditional between them. So from right to left, looking at these two highlighted columns. So in the first row, we're going to have 0 to 1, which is true. In the second row, we're going to have 1 to 1, which is true. In the third and fourth row, we're going to have 0, arrow, 0, and both of those are true. So what we have here is that in this final column, for P or Q and not Q, arrow P, this is all true. So this is a tautology. So because we have a tautology for a conditional, what this means then is that P or Q and the formula not Q entails P. And we can think of this and as just the word and. So whenever we say this and this and this entails something else, we can just use the and operator to connect all of those. So that's it as far as tautologies, contradictions, contingencies, and entailments. Basically, this whole week has been about translating English sentences and drawing truth tables. All we've really done in this video is given names to those final columns for how the ones and zeros are arranged. So if you're able to do the truth tables, and you're able to translate English sentences into propositional logic, then this next step is really just like one tiny extra thing you add onto a truth table. And typically when I ask you questions, especially on test 3, if something is a tautology, a contradiction, or a contingent formula, or if there's entailment, you're already doing the truth table for it, so it's just that one extra step to give it a label. Anyways, if there's any questions this week, feel free to ask on the discussion board or email me, and I'll get to you as soon as I possibly can.